It is with us actually right now today. The possibility of electric in eVTOLs and other applications we understand through the day-to-day and in previous presentations, previous conventions, has many, many challenges. But as we talk about revolution, part of what we're doing with electric aviation is evolution. Conventional electric aircraft don't have the leap in terms of the amount of energy required to fly, to perform a mission. But the innovation around electric with a conventional airplane has the ability to take what's known, the existing infrastructure, the airports, the flight training schools, etc., and apply the benefits of electric to solve an immediate and compelling problem. I'm an engineer, University of Washington. I went into the Air Force. I trained fighter pilots in the 1980s. I went to Desert Storm, and then have been in industry, Raytheon and Boeing, and now, of course, by Aerospace for the last 12 years. When I first started my pilot training, actually my mother and father owned a Piper Cherokee. And I learned to fly. My mother was a pilot first, actually, in our family, so it's kind of cool. My mother was the innovator. That Piper Cherokee is flying still today. When I got my pilot license in 1977, before starting my career in the Air Force as a pilot, I learned to fly on a Cessna 172. Galvin Flying Service at Boeing King County Field in Seattle, Washington. That Cessna 172, 10 years old at that time, is still flying today. General aviation is old. Internal combustion engines on general aviation trainers go back 50 and 60 years. According to the FAA, there's 10,000, a little bit more, FAA-registered flight trainers in the United States. Maybe 11 to 15,000 worldwide. Those flight trainers are at the end of their useful life. Those flight trainers today are producing between 5,000 and 7,000 new airline pilots per year. We ponder that for a minute, and we think about right now today in the US, we've got about 150,000 airline transport pilot rated commercial pilots flying United, Delta, etc. 30% of our pilots are retiring in the next 3 years. According to Boeing, we need 40,000 new pilots per year. 804,000 new pilots over the next 20 years. It's not a spike. It's not an urgent thing to solve tomorrow. It's a requirement for the next 20 years. And 30% of us are retiring in the next 3 years. Electric aviation has the possibility of an immediate requirement to replace an aged fleet of internal combustion engines on legacy aircraft with new, clean electric aviation. But the part that makes that work, the part that makes a business solution that's so important for us to address, is that 80% of our students today in flight training drop out. And what the compelling reason, the reason that keeps them from completing their training is cost. That legacy fleet of trainers costs about $50 per flight hour in avgas, compared to $3 per flight hour for electricity. I love the fact that we're not creating any CO2. I love the fact that electricity is clean and cool, it's high tech. We're going to create the most amazing advanced electric training aircraft the world has ever seen. But it matters because we have a compelling business reason, we have a compelling social and cultural and transportation issue that we need to solve. And electric aviation uniquely can address that issue. So 5,000 to 7,000 new pilots created today from a legacy fleet of about 10,000 airplanes, needing to create instead about 40,000 new pilots per year. So you can see from a addressable market, from a numbers, from a business case, we need probably in the neighborhood of 50 or 60,000 new airplanes just for training. An immediate opportunity, a compelling opportunity, and a very interesting one as well. So we look at the characteristics of electric. No CO2 is produced. In the combustion of avgas, of course, oxygen is consumed. In a typical flight school, literally about 5 million pounds of CO2 are produced, 25 aircraft flight school. What's interesting about airplanes is that we have a relatively low noise signature with electric. We don't have the high frequency, high density propulsion that you have to have with an eVTOL. So electric aviation is quiet. Literally at 500 feet, it's indetectable to the human ear. So no CO2, no noise, but perhaps most importantly, very, very low cost. So the barrier to entry for new student pilots is addressed by reducing the cost of operating these aircraft by about 5-fold. So 804,000 pilots needed over the next 20 years. That's translated to about 40,000 per year. The cost in total, when you add up all of the hours required to become an airline pilot, is about $150,000 to $200,000. So it costs about the same to become an airline pilot as it does to become a doctor or a lawyer. And that barrier to entry for a new pilot is addressed in large part with electric. Electric aviation, electric conventional aviation immediately can address and help address this very great requirement. Now, we like to talk about the airplane as a whole. It's flying today, as you could see. We're about halfway through the FAA certification process. Conventional aircraft certification with electric propulsion has been approved by the FAA. The new FAR Part 23 Amendment 64 fully allows for an electric conventional aircraft. And of course, airspace, runways, and so forth already exist for the mission of training. So the E-Flyer 2 is well underway. Of course, we also like to say it looks nice. The aerodynamics for an electric are very pretty, very sleek, very low drag. This has the aerodynamic efficiency of 21.5, an L over D of 21.5, a lift to drag ratio or about twice the aero efficiency of a Cessna 172. Our partners have kind of caught the vision of the possibility of what electric aviation might be. Rolls-Royce, Siemens, Garmin, great strategic partners investing with us into this cornerstone, starting with a 2-seat electric trainer. 3 hours of flying time, 135 knots, absolutely no compromise in terms of performance. We outperform the Cessna and Piper legacy aircraft by a significant margin. But again, most important, the low operating cost. A Cessna 172, a brand new one, is about $110 per flight hour. A Cirrus SR-20, even more. About $23 per flight hour with the maintenance reserve, with the battery reserve, all in, 1/5 the cost of the conventional flight trainers in use today. The interesting thing, I know this might be a little bit of an eye chart for those back in the back, but basically speaking, this aircraft is larger and more comfortable, has more payload, and completely addresses the flight training requirements, the syllabus for which the airplane has been designed. From the outset, an ideal flight trainer. We go from the E-Flyer 2 to the E-Flyer 4. E-Flyer 4, a 4-seat version, same systems, same structures, same aerodynamics, very, very efficient. $3 of electricity for the E-Flyer 2, and a little bit larger E-Flyer 4, about $5 of electricity. But with the larger capacity, and still the incredible operating economics, other possibilities come to play. Air taxi, the ability to carry people or cargo efficiently for very, very low cost becomes a possibility with conventional electric. And the infrastructure already exists today. In Los Angeles, for example, there's 30 airports underutilized today that can provide access for those who would like to fly and perform a mission or have a business use or a requirement to move cargo. So E-Flyer 4 takes all of the benefits of E-Flyer 2 and opens up a new market. Flight test is underway today. As I mentioned, we're about halfway through the FAA certification process. We're about 18 or 20 months out from achieving FAA certification, and the access to market with our partners in the market will begin about mid-2021. It's kind of interesting. For those, how many of us here are pilots? So, that's kind of fun because we have a lot of pilots here. So 10,000 feet density altitude, Denver, Colorado, summer day. 10,000 feet density altitude. What rate of climb would you expect with a Cessna 172? You're just about done, right? We're climbing at 750 feet per minute. We're climbing better at 10,000 feet than what a Cessna 172 does on a standard day at sea level. The benefit of electric is a larger flight envelope, more flight training days, and a more efficient flight training syllabus. It's not just a lower cost syllabus, but it's a broader opportunity to fly when other aircraft aren't able to fly. Designing the airplane from the outset for certification has been critical. We've worked with the FAA. This is clearly a new pathway. We're pioneers. Some people ask us, well, how long has Aerospace, been a startup? And of course, we're 12 years old, and I love that. There's a tenacity and a persistence, of course, required with any new paradigm, and electric propulsion is no less than many others have already described. But from the outset, we've been designing for certification. A certified motor, a certified battery pack. Our partners have bought into the outcome of a certified product. And working together with the FAA, the collaboration of team, I think, has come together with great success. Some kind of interesting pictures of the aerodynamics of the airplane. As I mentioned, very, very low drag, very high aero efficiency. We don't have the cooling drag and the inefficiency of the internal combustion engine anymore. So in conclusion, we're very, very pleased. I hope at the end of this first day to talk about the exciting news that electric aviation is really here. It's here today. We're flying today. The projections, the business, the performance of the airplane is happening right now, today. And together as a team, the collaboration of all of us together can make this real. Thank you very much.
You've got hundreds of questions. We're running out of time. So very quickly, how much does it cost?
So,
is there a deal today?
Yeah, it's a little bit less than a conventional equivalent airplane. So a Cessna 172 is about $450,000. We're about $400,000 for the two-seater, and about $500,000 for the four-seater. Again, roughly equivalent to the Cessna or Piper or Cirrus equivalent.
And any comments on Rolls-Royce buying Siemens?
Yeah. So Siemens e-Aircraft has been in the business of developing these electric motors. Some of you in the eVTOL business have been looking at Siemens, and I'm sure others. We're very pleased to work with them on the eFlyer 2 motor, the SP70D. It's a great motor, lots of success and many challenges. Rolls-Royce wants to get in the business. And of course, M&A has been part of aerospace forever. So we look forward to working with Rolls-Royce as well.
Brilliant. Thank you very much. That was brilliant. Thank you.